So, what you're going to have is a variable underneath a radical. And in order to solve those equations with the radicals, we got to get the radical by itself first on one side. Okay, and then we're going to get rid of the radical, and I'll show you how to do that. And then we have to check our answers. Okay, and you always have to show your check. What can happen sometimes with these radical equations is we introduce solutions that actually aren't true. And so when that happens, we have to eliminate those solutions because they actually don't work. So we have to be careful, and that's why we have to do and show our check every time, every equation, and you have to write it out. Okay. So here's an example of a radical equation. The cube root of x plus 2 equals 3. And we have to try to figure out what x equals. We've talked about inverses earlier in chapter 6. The inverse is something that's kind of the opposite, right? What is the inverse of cube rooting? No, square rooting is another type of thing, but it's not the inverse of cube rooting. Well, let's talk about square root. What's the inverse of square rooting? How could you make a square root go away? It's the opposite of that. What does the cube root really mean, or the square root really mean? Like when I find, for example, the square root of 81. What is that? 9. How do you know that that's 9?
Because it's
Factors of
9 squared.
Say that again?
It's 9 squared.
9 squared gives me 81. So squaring and square roots are inverses. So if that's true about squaring and square roots, what do you think is an inverse of cube roots? Cubing, which means raising it to what power? The third power. So what we're going to do when we get the radical by itself, we're just going to do the inverse of the cube root or the square root, depending on which problem we have. Okay? And so in order to make this radical go away, all I'm going to do is raise both sides to the third power. Okay? And that's why we have to get the radical by itself. When we raise that whole side to the third power, this cube and cube root end up canceling out. So that's why we do it. Okay? So this cube root and that cube cancel out. So what am I left with on the left side?
I think it's square root of x plus 2.
No,
27.
X plus 2.
just x plus 2. Okay, so on the left I'm left with just x plus 2. What's on the right? 3 to the third. What's that equal? 27. 3 to the third. So here's what I really get. Okay, the cube root and the cube cancel, leave me just with the x plus 2. 3 to the third is 3 times 3 times 3, which is 27. So what does x equal here?
25.
25. So right, subtract 2 sides, x equals 25.
Wait, what crossed out?
The cube root and the cubing cancel, so I'm left with just this x plus 2. Whatever the index is, that's what you do to the power. So since this was a cube root, I took it to the third power. If this was just a square root, I take it to the second power. If this was a fifth root, then I take it to the fifth power. So the goal is to get, you raise it to the power that's the same as the index so they cancel out. Okay? Now, I have to check and make sure that this actually works out. So what you do is you go back to the original equation and you plug in 25. And we're trying to really see, does this equal 3? Okay. Well, 25 plus 2 is 27. So the cube root of 27. What is that? Cube root of 27. What to the third power gives me 27? 3. So it works. 3 does equal 3, so I'm good. And so it does check, and there's my, now I can circle my answer. I'm confident that that is the correct answer, okay? That's how problems like this work. Questions? Let's look at another example, okay? This one's similar, but there's a couple differences. What's one difference in this problem compared to the last problem?
Radical's not first.
The radical's not on the left side, it's not first, okay? What else is different?
There's three things underneath the radical.
No, there are not 3 things underneath the radical. Is this minus 1 underneath the radical? No, it's not. Okay, is the radical by itself?
Yes.
Max, you say no, why?
As the number, it's not. The equal sign is not on the other side. It's not saying equal 1, right?
Right.
So it's not.
What is preventing the radical from being by itself on this side? The 1. Right, so I've got this minus 1 over here that prevents the radical from being alone. And I have to get the radical alone first. What else is different? There's one other thing that's different. Besides the numbers being a little bit different. What's the last thing that's different? What kind of root did we have in the first problem?
Square.
No.
Third is cube.
Cube root. We had a cube root. What do I have in this one?
Square.
Square root. Okay? So there's a lot of differences actually. So because the radical is not by itself and this minus 1 is preventing it from being by itself, I have to get rid of this minus 1. How do I do that?
Add it to the other side.
Add it to the other side. I'm going to add 1 to both sides, and then the radical will be by itself. Okay, so I've got the square root of x minus 2 now equals 6. So now that I've gotten the radical by itself, what kind of radical is this?
Cube.
Square root. What's the index here? 2. So what do I have to raise both sides to? What power? The second power. So if I raise both sides to the second power, the radical and the power will cancel. So that side now just is x minus 2. What's the left-hand side going to equal?
36.
36. Okay. So what's x?
38.
38. Add 2 to both sides. Okay, what else do I have to do?
Check your.
Check it. Now when you check, here's what's really important. You have to check at the original equation. So the very top equation is what I have to use, where I plug 38 in for x. Do that over here. And I skip some steps. But we notice that 38 minus 2 is 36. What is the square root of 36?
6.
6 minus. We're good. Let's look at another. Okay, this one's a little bit different. Again, it does have a square root like the last problem, so that's similar. It's still not by itself, so that's different. Well, that's similar to the last one, but different from the first one. Okay, so I still have to get the radical by itself. Why don't you try it? Why don't you try this one? What's your first move going to be?
Subtract 4.
Subtract 4. Correct. Subtract the 4, because the 4 is preventing the radical from being by itself. If I subtract 4 from both sides, the radical's by itself. Try to finish the problem. So when you squared both sides, okay, hopefully that's what you did, the radical and the square cancel, so I'm left with just 2x plus 7. Negative 1 squared is positive 1. Then you subtracted 7 from both sides, you divided 2, and you got x equals negative 3. How many had x equals negative 3? So mechanically you did it right. Now you got to do your check, right? When you plug it in, here's what you get. Now here's what's important. When we do our check, it has to be in the original equation, and you want to make one side equal the other side. So when I do that, okay, this gives me -6. Some of you had -8 for some reason. Moving on. So this is -6 plus 7. Okay, which is 1. What is the square root of 1? 1. And that's 5. 5 does not equal 3. So what does this tell me?
No solution.
Yeah, that tells me I gotta throw that answer out. This one's gotta go. This does not work. So there's no solution to this problem. Now, I want to show you one other thing that you may have recognized. Did anybody recognize that this was going to be a no solution before going through all those steps? Okay, let me show you why we know that. And my goal is for you to be able to get to this place at some point. But if you don't, that's okay. Your check, double check your check. If you did it right, then you'll end up with something like that and throwing solutions out. Okay? But here's where I want you to get to. Okay, at this step right here, before I did any of that work,
Because it became a negative.
you cannot take the square root of a number and ever get a negative. Ever. Right? You can't take the 4th root or the 6th root or the 8th root. You can take the cube root and get a negative. You can take the 5th root and get a negative. You can take the 7th root and get a negative. But if the index is even, square root, 4th root, 6th root, 8th root, you can never get a negative. For the same reason we talked about at the very beginning. Right? There's no way to square a number and it equals a negative. Just like we're talking about here.
Can a cube number equal a positive?
Cube number can equal a positive, a cube number can equal a negative. Okay? But when you multiply things together an even number of times, it always has to be positive. Now,
is a positive positive?
there's a positive, right? But I can't take a negative times a negative and equal a negative. So that's why this doesn't work. Okay? And so, eventually what I want you to do is be able to go, look, a square root cannot equal a negative. There's no way this is going to work. And with that, give me a little explanation. Tell me, a square root can never equal a negative. That kind of thing. Okay? Now, if you don't recognize it and you follow it through the way we did, and you get a solution, and then the check doesn't work, that gets you the same answer. Takes a little more work. Eventually, I'd like you to get to a place where you don't have to show all that work because you recognize, hey, this is a problem. Okay? For that matter, if you want to continue it through anyway, just to prove it, you're welcome to do that. Okay? That's it. Questions? Let's look at one problem real quick together before you get too far into it. If I have a problem like this, okay? So you have a few problems in your homework that look like this, right? And you might say, well, we didn't do any problems like that. Well, what does this 1/3 power really mean? Not quite cubing it. It would be a 3 if we were cubing it. When it's 1/3, what are we doing?
Would you divide it?
Nope.
It's 3 and there's 1.
So what type of thing are we talking about when you have that rational exponent? We just got done working on this. Nope.
Okay, so the 3 goes, it's 3 goes right there, like it's cubed.
Uh-huh.
The problem's cubed, and then there's 1 on the 3. Like
But there's one really important thing you're missing.
It's in parentheses and there's a 1.
But what is the big thing we're missing? There's a symbol. A giant symbol. We just got done doing a bunch of problems like that.
Division.
No.
Radical?
A radical. This means the cube root.
Yeah.
But you weren't saying that.
Okay.
So what this really means is this. So when you get to a problem like this, just change the the rational power to a radical. We just got done doing that in 6.6. Okay? What would it be if it was a square root? What would the power be?
2 square.
No.
Whatever the square root was.
If it was a square root, what would the rational power be? Cube root is 1/3, so square root is what?
It is pouring.
Say that?
2.
not 2. No. This means cube root. So what's the fraction that means square root? 1/2. So if you see a 1/2, then you know it's square root. If this was 1/4, it'd be 4th root. Okay? We just got done talking about that in 6-6.